Well, my dear, the main purpose of recollecting all those things is as and when you look at y dx minus x dy by y square, you must be able to recollect that this is the differential of y by x. So to integrate it, we'll have y by x plus c, like that. That is the very benefit of learning all of them. The next one is, what is d of log of x by y? Think of it carefully. Treat this as x. Log x means 1 by x. 1 by x by y means y by x. Y by x into derivative of that. What is derivative of that? Y dx minus x dy by y square actually. Actually it is y square, and previously 1 by x by y is there, that is y by x is there. One y will be cancelled, isn't it? So that what happens to the denominator actually? So the actual formula for that is y dx minus x dy by xy is d of log x by y. Okay then. Now you try to imagine, you try to tell me d of log y by x. What is that? What is that? D of log y by x. Same old formula. This is x dy minus y dx by xy. That's all. So, as and when you look at x dy minus y dx by xy, you must be able to recognize that it is nothing but d of log of y by x. One more thing I require from you, d of log of x square plus y square. Come on, tell me. Come on, what will be? Log of x square plus y square. By x square plus y square is compulsory. And in the numerator, for x square plus y square, it is 2x dx plus 2y dy, isn't it? So it is 2 into x dx plus y dy. This is the 8th formula. After noting all of them, let us gather those things which have similarities, which have differences, so that it will be an easy process, of course, to recollect and reuse them, to remember them also. One more. D of tan inverse x by y. What is that? D of tan inverse x by y. What is that? Let us first of all derive that and then use it in the list of the formulas. Look here, you treat this as some x, 1 by 1 plus x square into derivative of x by y is y dx minus x dy by y square, isn't it? Come on friend, what is the numerator? Y dx minus x dy by y square into 1, y square into x square by y square, x square plus y square. How simple it is to remember. Y dx minus x dy by x square plus y square is just nothing but d of tan inverse x by y. Well done. What can you imagine? D of tan inverse of y by x? Absolutely in the similar fashion as that of this case. What can it be? Come on, come on. This is x dy minus y dx by x square plus y square. It is nothing but d of tan inverse y by x. Nothing but d of tan inverse y by x. Okay, one more thing. D of e power x by y. What can you see? Come on. E power x into y dx minus e power x dy by y square. So y into e power x dx minus e power x into dy by y. Like that you can create as many as you like, as you want, as you enjoy, as you please. There is no question of any end to that. The only purpose of introducing them on the screen, on the board, is you must be able to know the style of creating them. Thereby you can remember the original differentials. We shall now gather the similarities among all these differentials. Look here. X dx plus y dy. X dx plus y dy by x square plus y square. With x dx plus y dy, these are the only things we could have come across. What is this x dx plus y dy? D of x square by 2 plus y square by 2. What is this x dx plus y dy by x square plus y square? This is half into d of log of x square plus y square. Previously, we could have had just the list of differentials, and in the present moment, we gather similar differentials in one box so that it will be very easy to remember them. This is the first box we want to prepare. Well done. Next one. Y dx plus x dy. Y dx plus x dy by xy. Y dx plus x dy by 1 plus x square y square. In these three formulas, numerator is same, you see, y dx plus x dy. This is nothing but d of xy. This is nothing but d of log mod xy. And this is nothing but d of tan inverse xy. Please note them down. These are very important. You join them to your memory box. Yes. Let us now create the third variety of boxes. Another variety, you look at that. Y dx minus x dy by y square. Y dx minus x dy by xy. Y dx minus x dy by x square plus y square. Okay, this is nothing but d of x by y. This is nothing but d of log of x by y. This is nothing but d of tan inverse x by y. Let us create another such box so that we will be able to understand the comparison of these two boxes. X dy minus y dx by x square. X dy minus y dx by xy. X dy minus y dx by x square plus y square. This is nothing but d of y by x. This is nothing but d of log of y by x. This is nothing but d of tan inverse of y by x. This is the second box of the same pattern. You might have understood one particular thing. There is a lot of scope for being confused. How to catch it, how to remember them. Look here. Dx occurs in the beginning, so it is x by y. If numerator starts with dx, denominator must be y square. Numerator starts with dx, numerator starts with dx. X by y, x by y, x by y. Observe the same here. Numerator starts with the dy, x dy. Then automatically the denominator will be x square. Then it is the differential of y by x, isn't it? Of y by x. Starts with dy, log y by x. If it is xy, logarithmic function is there. If it is x square plus y square and minus sign in the numerator, it is of tan inverse function. You see, previously we could have had another differential with the denominator as x square plus y square. Could you remember that? Let me try to reproduce it again. X dx plus y dy by x square plus y square. Have a strong look over these two, my dear. You may be got confused. Please don't get confused and do not confuse others. Look, x dx, y dy with plus sign in the middle. X dy minus y dx with minus sign in the middle. Of course, even though the denominators are same, there is a lot of change in the numerator. Basing on which we choose the proper differential. So it is a d of tan inverse y by x, and this is d of log of x square plus y square. Well, you keep a special eye on these to watch them very carefully. We shall be using these things as and when we come across such differentials while solving the differential equations. We have not yet started actually. We are just knowing the introduction about the way of solving, and we have not touched with all the models. We are just at the first model, namely a variable separable or simply variable separable. Now we shall turn our head towards solving some more special problems in these differential equations using the method of variables separable. Note them down, these two boxes. These are very important, very cunning, very confusing. Yes, of course, you have to catch the actual loophole among them, the actual concept involved in them. Yes, note them down. After going through the theoretical part or the conceptual part or methodological part in solving differential equations, we shall try to solve some simple and special equations in which variables separable method is necessary. Look at the first question on the board. dy by dx is equal to e power x minus y plus x square into e power minus y, and y of 0, y at 0 is 0, then y at 1 is, you have to understand y as f of x. Okay, let us try. Look here. I would like to write this as e power x by e power y plus x square by e power y. Any doubt? So this is x square plus e power x by e power y. This is all dy by dx is equal to, you just cross multiply, e power y dy is equal to x square plus e power x dx. integrating on both the sides. Integral of this is integral e power y dy is equal to integral x square plus e power x dx. Implies what is the integral of e power y? E power y is equal to x cube by 3 plus e power x plus k, where k is the constant which is supposed to be determined now. Okay. But y at 0 is 0. What is the exact meaning of that? The value of y at x equal to 0 is 0. So it passes through the origin, isn't it? Therefore, e power 0 is equal to 0 cube by 3 plus e power 0 plus k. 0 by 3 is 0, e power 0 is 1, e power 0 is 1, 1 and 1 will go away, leaving you k is equal to 0. So, k is equal to 0. Hence, e power y is equal to x cube by 3 plus e power x only. Hello friend, we are not just supposed to have y at 1 we want to have. That is, after getting the solution, you are supposed to take 1 in the place of x. What happens? Therefore, e power y is equal to 1 cube by 3 plus e power 1. We are substituting x as 1 and we want to get y. Let us see. So, e power y is equal to e plus 1 by 3. From this, y is equal to log of e plus 1 by 3 to the base e. So, what is y? What is the value of y when you put x equal to 1? Log of e plus 1 by 3 to the base c. That is the answer. Therefore, y at 1. What is the actual and exact meaning of y at 1? Value of y when x is 1. Come on, what is that? Y of 1 is equal to log of e plus 1 by 3 to the base e. Of course, ln e plus 1 by 3. That's it. That is the answer. Please note down these steps. Another simple question is ready for us. It is readily available on the board. Look at that. 1 plus x square into dy by dx is equal to 1 plus y square, and y of 0 is 1. What is y of 2? Let us see. By changing the variables conveniently, it can be written like this. Any problem? Dx by 1 plus x square. Okay, variables have been separated. That is why this problem is thrown in the model variables separable model. Okay. Integrating dy by 1 plus y square is equal to dx by 1 plus x square, integral of. What is its integral? Tan inverse y here, tan inverse x plus some k you have to write. But depending on situation, I like to write it as tan inverse c. Because except this, every other part in the solution is in the form of tan inverse something. Where lies the sin in estimating or imagining the constant also in the same form? There is no problem. Let us imagine it. So that it is tan inverse of x plus c by 1 minus cx. Tan inverse y is equal to. Okay, implies y is equal to x plus c by 1 minus cx. But he has given that. What has he given? Y of 0 is equal to 1. That is, if x is 0, then y is 1. So what happens? 1 is equal to 0 plus c by 1 minus 0. So what can you say? C is equal to 1. As in when you see that c is equal to 1, what is y? X plus 1 by 1 minus x. Is it necessary to is it sufficient to have y only? No, we should have y at 2, isn't it? Therefore, y at 2 is 2 plus 1 by 1 minus 2 is minus 3, isn't it? 3 by minus 1. So the required answer is minus 3. The next problem is ready for us. We go through that. It is available on the board. X cube dy plus xy dx is equal to x square dy plus 2y dx. It has been given that y at 2 is g, and we are asked to have y at minus 1. Let us try. Look here. Let us rearrange the terms so that this problem can be thrown into the model of variables separable. Let us try. X cube dy minus x square dy is equal to 2y dx minus xy dx, isn't it? So that it is x cube minus x square dy is equal to y into 2 minus x dx. 2 minus x dx implies dy by y is equal to 2 minus x by x cube minus x square dx. 2 minus x by x square into x minus 1. Not 1 minus x. So, x square minus x into x minus 1. X square and minus x square will go away. Minus x into minus 1 plus x is there. Minus 2 into x minus 1 by x square into x minus 1. Now you observe x square minus x into x minus x square, they go away. Minus x into minus 1 plus x minus 2x is minus x plus 2 is there. This is the right way of splitting it. So that this is equal to x square by denominator 1 by x minus 1. Second term by denominator x minus 1 and x minus 1 go away, x by x square minus 1 by x. Third term by denominator x minus 1 and x minus 1 will go away, minus 2 by x square dx. Now you observe, you note them down. Therefore, the last step is dy by y is equal to 1 by x minus 1 minus 1 by x minus 2 by x square dx. Let us now integrate it with respect to x on both sides. Y is equal to, what is the integral of 1 by x minus 1? Log mod x minus 1 minus log x minus 2 by x square minus 2 into, what is the integral of 1 by x square? Minus 1 by x plus c. Plus c. Therefore, y is equal to log of log mod x minus 1 minus log mod x plus 2 by x plus c. We are now to make use of y of 2 is equal to e, but y of 2 is equal to e. What does it mean? E is equal to log of 2 minus 1 minus log 2 plus 2 by 2 plus c. Log 1 is 0, 2 bar is 1. Therefore, C is equal to E plus log 2 minus 1. E plus log 2 minus 1. Okay, let it be like this. What do you want actually? We want to have y at minus 1. Therefore, y at minus 1 is y is equal to log mod minus 1 is minus 2. Log mod minus 2 is log 2. Mod minus 1 is 1. Log 1 is 0. Omit it. 2 by minus 1 plus C. What is C? E plus log 2 minus 1. All together, log 2 plus log 2, 2 log 2 plus E. 2 minus 1 is minus 2 minus 1 is minus 3 is the answer. Is the answer available?